Welcome to Challenging Climate, a podcast where we discuss the science, technology, and politics of climate change. I'm Pete Irvin, a climate scientist.
And I'm Jesse Reynolds, an environmental policy expert. Each episode, we bring on a guest with a unique perspective and deep expertise on climate change and put challenging questions to them.
In this episode, we wanted to respond and do something about the latest IPCC report. The Intergovernmental Panel on Climate Change has produced the second report in its trilogy. This time it's on impacts, adaptation, and vulnerability. These reports are gigantic, and we didn't want to just summarize the summary. We want to take a step back. I think each of the topics, getting a deep understanding of the various impacts of climate change, I think each of them deserve their own episode, and I'm excited about having episodes in the future on biodiversity impacts of climate change, looking at forest fires in depth, thinking about the challenges of adapting to sea level rise. These are all topics that I don't know enough about, and I'm sure many of you would like to know more about. So we're excited to have conversations on those. So here we take a step back and do a bigger picture. And in 2 episodes' time, we're going to do a similar thing for Working Group 3. So we're really excited to have Professor Rob Lempert joining us. Now, he was a coordinating lead author on Chapter 1, which sort of sets the scene for the report and introduces the key concepts. In our conversation, we draw on his 30 years of experience writing on climate change to give that longer term perspective. What's the IPCC? What's it for? How's it evolved? What are the key concepts that we need to grapple with when thinking about climate impacts? What were some of his big takeaways? And how has the IPCC evolved over time and responded to criticism?
Rob's work outside of climate change is itself quite interesting. He works in decision science or decision theory, understanding how humans can and should make decisions. So we touch on the science of decision making, particularly under conditions of deep uncertainty, and how can we make decisions in such a context. We bring it all together to circle back around to climate change to talk about how scenarios are used in decisions in general, but particularly in the climate change context, what's worked recently and what might be able to be improved.
We really enjoyed the conversation. And if you want to get a bigger picture take on this new IPCC report, then I think this would be a great place to do it. All right, it's my pleasure to introduce Professor Robert Lempert. Robert Lempert is a principal researcher at the RAND Corporation and director of the Frederick S. Pardee Center for Longer Range Global Policy and the Future Human Condition. His research focuses on risk management and decision-making under conditions of deep uncertainty, and he's been writing on climate change for almost 30 years. Robert, welcome to Challenging Climate.
Thank you so much. Pleased to be here.
Let's begin with a question that we usually begin with, which is a little bit about your background. Can you tell us how you ended up at RAND and how you ended up working on the issues of climate change and decision making?
I've been at RAND most of my career. My training is in condensed matter physics with a mix of political science and science policy mixed in. And I'm actually the scientist in a family of politicians. So I came to RAND because which is a nonprofit public policy research organization based in Santa Monica, California, with offices around the world. And came to RAND because I was very interested in science policy, the intersection of science and policy. Came into working on climate change because I became very interested in, both the topic in and of itself. And I started when James Hansen, gave his famous testimony before Congress in 1989, but also just the intersection of what's become called the steep uncertainty question. How do you use scientific models, economic models to inform policy in a world, the one thing you're certain of is that you're going to get surprised. And climate change is, in some sense, the archetypal example of that policy issue. And so that was my entree into this whole topic area.
We'll be talking a lot today about the Intergovernmental Panel on Climate Change, the IPCC. Rob, can you tell us what the IPCC is and how did it get to where it is now with this new report?
Yeah, the IPCC is a United Nations scientific assessment, And so what it does is it brings together a large group of scientists from around the world, and we are tasked with reviewing vast bodies of literature and coming up with an assessment, which is really more than a review or a summary, but a statement of what we know, what we don't know, we being the scientific community, and what the implications are for policy. I think of it, and using this fancy political science term, as an epistemic community. What it's essentially trying to do is create a worldwide group of scientists, each of whom are, the advisors to their governments, to their societies, and helping them come to a common understanding of what we know and what we don't know, so that the policymakers have this information base they can come to. We're in the 6th assessment cycle, which are about every 5-6 years. And we've just this last Monday come out with a major new report assessing of impacts, adaptation, and vulnerability.
When did you get involved in the IPCC?
I was originally involved back in the 2000s as what they call a contributing author. IPCC, fairly a bureaucratic structured operation. A contributing author is asked to contribute a few paragraphs or a page of text. Started that way. I first came in as what's called a lead author, and that's someone who comes to the meetings, is assigned to a chapter, and has responsibility over not only what they write, but as part of the team effort. In the 2012 SREX report, or the report Extreme Events and Adaptation, an attempt to bring together the disaster risk management community with the climate change adaptation community and get those two groups talking to each other. So I've been involved for about 10 years.
You mentioned we're on the 6th assessment report cycle. So the IPCC's main reports are divided into 3 main parts. There's 3 working groups, and each working group produces its own report. And the report that came out just this week, the one where you're involved in, is the so-called Working Group 2, Impacts, Adaptation, and Vulnerability. Why is the IPCC's work organized in this way, and how does Working Group 2 fit into this architecture?
This is actually a great topic, and I hope we can get more into how the IPCC has divided itself up. But it's divided, as you say, into 3 working groups. Working group 1 is the physical science basis. So it's essentially the climate and earth scientists writing about what we know about observed climate changes and how we project the climate and earth system will change in the future under various scenarios of emissions and other human influences. Then we working group 2 people are supposed to come along and say, what are the impacts on people and ecosystems, essentially, things that people directly care about from those changes in the climate and earth system. And then how might we be able to adjust to those changes, adapt or adjust to those changes. And then next up is going to be working group 3, which will come out this cycle in April, I believe, which is on reducing greenhouse gas emissions. How do we reduce the magnitude of climate change by reducing emissions and now increasingly also potentially extracting carbon from the atmosphere? The IPCC was originally set up and still largely is to advise the national governments, which are parties to what's called the Framework Convention on Climate Change. They're the ones that get together and produce the Paris Agreement and other agreements to address climate change. So the original structure is really, what's happening in the climate system, what are the costs of allowing climate change, and then how might we reduce it in some basically sort of a benefit cost framework so the negotiators can decide what emission targets, reduction targets we ought to have. Though it's now expanding way beyond that, because it turns out that climate change is both a bottom up as opposed to as well as a top down problem. So there's a much larger audience of people who ought to be aware of the impacts and what might be able to be done about them.
In this report, I believe you're a coordinating lead author on chapter 1 of this working group report. So what's your role as a lead author? And governments get involved at some stage, which is a little unusual. Do they get involved at the chapter stage?
Yeah, the official phrase is that the scientists and the governments co-produce the report. And the way that works is the governments get together at the very beginning and commission the new assessment cycle and commission an outline of each report. So governments nominate authors. The IPCC puts together what they regard as a good set of a good author team for each of these assessment reports. Ours, Working Group 2, has about 275 authors who are spread out over 18 chapters and 7 cross-chapter papers. There's a little bit of overlap among those, but essentially each chapter's got about a dozen authors. They're called lead authors, and then among those authors, 2 or 3 of them are what they call coordinating lead authors, and we're essentially the chairs of the committees of about a dozen people that write each chapter. Our role is, chair of the writing committee and then lead the coordination among the other chapters. We spend a couple of years writing. We produce several drafts. Governments and then a larger community act as reviewers for each draft, and then we revise the draft based on the comments. At some point, the IPCC is going to release this gigantic spreadsheet with 62,000 comments, I think is what we got. So we have to respond to each one, everything from, oh my God, that's a great point. We'll have to rewrite this section, to a very polite version of, you don't know what you're talking about. We're going to ignore this. Then the report is fixed, and then we come back and with the governments approve what's called the summary for policymakers. The report itself is about 1,300 some pages. Then the summary for policymakers is about 35 pages, which is meant to summarize the main policy relevant points. That a smaller group of authors, about 60 of us, write the first draft of that, and then we spent the last 2 weeks approving and revising that line by line with the government. And then that was finished last Saturday around 2 p.m. California time.
Are there many tensions around when that kind of editing stage happens? I imagine if you've got different governments of the world coming together with quite different views that might conflict with the scientists, there could be some tensions.
Oh yeah, yes, a lot of tensions. The ground rules are the text of the report is bedrock, so you're supposed to refer every comment you have to that. But clearly the governments are trying to phrase things so it advances their particular political interests when they come to the next political negotiations. So yeah, it's a fascinating process. Relies on good chairs. The government states their case, and then the authors suggest revisions, and we go back and forth like that until we've got consensus on everything. Some sentences fly through just the way they were originally written. Others get revised for political reasons, and others get revised because the governments they are political actors. They're often really talented scientists. They've read the report in detail, and sometimes they see things which is, once they say them, it's like, oh yeah, no, you're right. We need to fix this. So they intervene on a bunch of different levels.
All right. So your chapter was the departure point and key concept. So it's the first chapter of the report. And so I thought it'd be quite nice to go through some of the interesting ideas that help make sense of climate impacts that are in this chapter. The one that really strikes me, and I believe it's like the most central concept or set of concepts, is this kind of equation that climate risk equals hazard times exposure times vulnerability. Can you unpack those terms?
Yeah, one thing that the IPCC has been heading towards, and I think is made a big step forward towards in this 6th assessment cycle, is to come up with a common risk framework over the 3 different working groups. Previously, the different working groups have not always embodied or embraced the risk idea and haven't always used it the same way. So there's been a big effort this time to actually make a common risk framing across across the entire working group. The equation you mentioned, the idea that risk is you take exposure, vulnerability, and hazard and multiply those together and get risk. Let me actually give first the definition of risk that is used in this report is the potential for adverse consequences for human or ecological systems, recognizing the diversity of values and objectives associated with such systems. And then it goes on from there. So it's this very broad definition of risk. But climate risk results from a hazard, which may be an extreme heat event, so some climatic event, which has the potential to cause damage. So for that to actually become a risk, people or something they care about or an ecosystem needs to be exposed to that hazard. You're exposed to sea level rise if you live in a low-lying coastal area. You don't if you live in the mountain. You need to be vulnerable, which means that you can be affected by the consequences. So one of the things that you find in this report is that often it's the poor and marginalized populations which are more vulnerable. So for instance, you are, say, more vulnerable to heat stress if you lack air conditioning, for instance.
I mean, it seems to me that Working Group 1 is perhaps the most straightforward of the reports, because there's been a 20 centimeter increase in sea level rise. Temperatures are projected to rise by between this number and that number. Whereas here, because you're dealing with these climate risks that are a product of both those physical changes and then the sort of socio-economic and other conditions on the ground and their changes, you've got a much more complicated picture to deal with. What actions are available to reduce climate risks other than emissions cuts, which obviously will reduce the amount that the climate warms?
Yeah, so first off, no, that's absolutely right. I mean, Working Group 2 in that way is much more complicated, much more expansive, because we're interested in not only the understanding the physical changes in the climate system, but how those interact with socioeconomic conditions, ecological conditions, and how those systems can change. In managing risks, one can reduce the hazard, which is fundamentally is the topic of Working Group 3. You reduce emissions, and that reduces climate change and hence reduces the hazards. And then the purview of Working Group 2 is what can we do about exposure and vulnerability. In some ways, addressing vulnerability is both in some ways the most simple and the most complicated. You know, there's a lot of incremental, relatively straightforward ways to reduce vulnerability. So for instance, we were talking about heat stress. And so in a city like Los Angeles, you can try to reduce heat stress by everything from painting the roofs white and paving the streets with lighter colored materials to do more reflecting of heats to cool things down. You can have actually more buildings in the old Spanish style, which actually are much cooler inside in hot days. You can make sure people have access to air conditioning, cooling centers, and that sort of thing. But if you start then, and there's a lot of attention to this in this report, start looking at the drivers of vulnerability, which are often things like economic inequality, marginalized populations due to race and gender and factors like that, you start saying, gee, one of the ways we really need to reduce vulnerability is to have some significant societal changes, move towards a more equitable society, move faster towards the sustainable development goals, reducing poverty, increasing education, and that sort of thing. So you start getting into some fundamental societal changes. On the exposure side, often that gets you quickly into, again, some more fundamental societal changes. One way to reduce the exposure to flooding, for instance, is to change the way we do land use patterns. People tend to build in floodplains because maybe it's cheaper, maybe it's pretty there. We need to change our land use policies, make the lower lying areas more parkland, and put the development where people live up on higher ground. In some places it can be a simple thing to do, but in other places it would require to have a fundamentally different way we fund and manage land and development.
Yeah, so I guess that brings up this issue of feasibility. So in theory, there are a whole set of things you could do to make the world or communities less vulnerable to climate change, but some of them are going to be pretty difficult. And it seems there wasn't as much as I expected on sea level rise, because this is one that I kind of worry about is how do we adapt to sea level rise? Where are the limits to adaptation? And where is it just going to be difficult to do?
First off, there is a cross-chapter paper on cities and settlements by the sea. So they are focused on sea level rise and try to deal with that. And so there's a lot of concentrated material there, and then there's a lot of sea level rise scattered throughout the report. The notion of feasibility is an important topic in the report. We talk about adaptation, which is this process of adjusting to climate change. That adaptation should be effective, meaning that it actually reduces risks and avoids what's called maladaptation, increasing other risks. So, if you push on the balloon, squish it down here, you don't want to pop out someplace else. It needs to be feasible, meaning you can actually do it. And then it needs to be just, conform to principles of justice. So the report does try to do an assessment of feasibility, and it has various categories where it ranks to understand whether it's economically feasible, politically feasible, technologically feasible, and so forth. And this is a relatively new set of topics for the IPCC. And as you know, it's real challenging, both because there's often the literature supporting that is not as extensive as it might be, because it's so context dependent. What may be feasible in one place, it may not be. And then also because feasibility may be very time and path dependent. What is feasible at one moment may not be feasible in another. And feasible for whom? A national government may have the power to do something, but it is reluctant to do it until the people support it, has political support. We see cases where nothing happens, and then all of a sudden, say there's an event which gets people's attention, and then all of a sudden becomes possible to do a lot of things that were not possible a week or two before.
I hadn't managed to get through the whole report before our call, but I did read through the summary for policymakers. And one thing that struck me there was it seemed to strike quite a more alarming tone than before on the risks that ecosystems face.
Yeah.
And also the importance of ecosystems in our climate resilience of societies today. Both, climate change is going to impact these ecosystems, but they're also critical to our stability today. Yeah, where does understanding stand there, and how is it changing?
Yeah, that is a really important theme in this report. But yeah, so there are two chapters, chapters 2 and 3, which focus on land-based and then aquatic and ocean-based ecosystems. And there is a lot more evidence. That's one of the areas where the science has moved a lot over the last 5 years or so in being able to document observed impacts to ecosystems. So in part, the science has been better. In part, observed impacts have become more significant over the last 5 years. But there are numerous places where we can now document really significant impacts of climate change on ecosystems. I think the number is half of all species are shifting polewards. Some ecosystems, for instance, coral reefs are reaching what's called the limits to adaptation. They cannot adjust anymore, so they're beginning to die off. And then we are the scientific community is beginning to do a better job of starting to project, the risk of extinction, which is starting to become quite high at higher global warming level. Really putting some concrete numbers under this idea that climate change, along with a lot of other drivers, is beginning to cause a mass extinction event. And then the report also then documents a lot of places where humans are reliant on nature, so that these changes are bad, not only just intrinsically, but because of their dangers to humans. And then it also has a real highlight on opportunities where learning to do a better job of living with nature and working with nature as opposed to get against it might make a really big difference. And the report has a bunch of examples of these, flood management, where using natural ecosystems around, say, floodplains can reduce the intensity of flooding. Same thing along coastal areas. or reforestation can reduce heat stress and so forth. And then it has a call for trying to leave between 30% to 50% of the Earth's landmass, put that into a more natural state.
Okay, so what was your biggest takeaway from the report?
I mean, there's a couple, but I mean, fundamentally, it's that, the impacts of climate change have arrived. In many cases, they're worse than expected. Adaptation can reduce risks and is reducing risk, but it's not keeping pace with how fast things are changing.
So stepping back a bit from the sixth assessment report specifically and looking at the IPCC process as a whole, where you've been involved for at least 15 years, maybe a touch longer, the IPCC receives diverse, mostly constructive criticism. Maybe it's too conservative by neglecting tail risks, that it assumes or privileges certain framings, that perhaps it's not the best use of the time of the hundreds of authors. Given your experience with the IPCC, what do you see as its current strongest point and an area where it could be improved?
I think the IPCC is starting to do a much better job with the too conservative question and starting to get its head around how to talk about more extreme events. It actually, on sea level rise, it, I think, does a really nice job in giving projections of future sea level rise. It both has a probability distribution of what we expect for sea level rise, and then explicitly lays out some high-end scenarios which don't have probabilities on them because there's not enough scientific understanding to put probabilities on them, but rather has what are called storylines. And it says, this is what would need to happen to get these really high level sea level rise things. So, and then in our section, we've got a discussion of this idea of decision-making under deep uncertainty, and then tries to link that description of sea level rise back to the idea of how you might have adaptive plans, which take action now, monitor both what's going on in the scientific community, what's going on in the physical world, informed by these storylines of what it would take to get extreme sea level rise, and reflect that back, and how would you have contingency plans and laying that out. So we're starting, I think, to get into how to provide scientific information about these extreme events in ways that become decision relevant. So I think that part is really strong. I think one of the things that the IPCC is struggling with is moving from essentially a warning device, which is, we've got a big problem, we ought to do something about it, and it's really urgent, to, okay, what do we do? Which is a different set of questions and a different audience. So it's the IPCC is trying hard to broaden the audience from national governments to a much wider range of governments at all levels, business, civil society, and so forth. It's trying to do, this report is trying to do a lot better job of providing, very fine scale regional information, so that there are everything from an atlas where you can go down and drill down and see what's going on in your region, to little fact sheets that summarize different parts of the world and give a summary of what the report says for that. But I think, moving from warning to providing information on how to respond, so moving from risks to solutions, is a challenge for the IPCC because it's a different set of information and a different audience.
In the first part of your answer there, you referenced decision-making under deep uncertainty, which is a topic that you've spent quite some time studying and writing on. Can you say a little bit about what you mean by deep uncertainty and how decision makers can and should approach such decisions?
Yeah, so deep uncertainty is meant to contrast to what might be called more well-characterized uncertainty. Sometimes it's risk versus uncertainty or irreducible uncertainty. But deep uncertainty is the condition where the parties to a decision do not know or don't agree on the likelihood of different futures, or how actions are related to consequences, or how to value different potential outcomes. And so Deep uncertainty is rather ubiquitous. It's contrasted to the set of, if we know the likelihood of different events, then you can apply your standard risk analysis techniques, which are ubiquitous across society. And that's what your insurance company does. That's often how engineers, design their buildings and that sort of thing. But deep uncertainty is this situation where we may have a lot of information, but we're likely to be surprised and likely to have things turn out very differently than we expected. Which is, once you say it like that, that's a fairly ubiquitous feature of any open system where there's a lot of interactions. We actually have an explicit discussion of deep uncertainty in the sixth assessment cycle. There's one in the ocean special report, and then it goes into it even more in this working group 2 report. But the basic idea is, first off, you acknowledge that you have deep uncertainty. It's important to understand that people make decisions under deep uncertainty all the time, so this is not a reason to freeze up, but it's a reason to think actively of a range of plausible scenarios and then think about how to make current actions resilient and robust across a wider range of futures. We talk in the report about things you can do. You can find low regret strategies, ones that work well over a wide range of futures. You can have more explicitly adaptive plans or adaptive pathways where you take an action, monitor, and then respond. So the report lays these out. There's obviously some tensions because there's a variety of challenges of actually implementing those sorts of policies. But the report does document places where those sorts of strategies to explicitly deal with deep uncertainty are being taken into account in adaptation plans around the world, and tries to lay out some ideas and some methods for addressing these sorts of uncertainties.
An area in which your topic of study, decision science, I suppose it can be called, and climate change overlap even more is this idea of scenarios. And I want to talk a little bit about scenarios. Could you give me a working definition of what a scenario is? Most people have kind of an idea. Yeah, it's something that might happen. We know worst case scenario, but could you be a little more specific about what a scenario is in your line of work or in the IPCC?
Yeah, so the IPCC defines a scenario as a plausible description of how the future may develop based on a coherent and internally consistent set of assumptions. A scenario in its purest form is a description of the future and how the future might unfold, which is meant to be plausible and internally self-consistent. And scenarios are most useful when they come in sets, so that they're exploring different ways the future might unfold. And they can serve a variety of purposes. Scenarios can provide a constant set of conditions, differing assumptions that then researchers can use, so you can compare one study to another. If one study finds the extinction rates are high and another finds extinction rates are low, you're comparing like to like, at least in terms of the scenario you're in, so you can do a better job of understanding what's the same and what's different between those studies. And the IPCC uses scenarios a lot in that way. We can get back to that in a second. Scenarios in this decision-making under deep uncertainty context can be used to expand people's worldviews or expand their view of the future. I mean, people do tend to have a tunnel vision as regards the future, often thinking, that what has happened will continue to happen, or what they say want to happen is going to be the thing that's going to happen. So scenarios can help expand people's worldviews. And they can also be used to stress test. So you can take, say, this is our plan, and stress test that against multiple scenarios and say, okay, this plan works well in these scenarios, but it fails pretty catastrophically in that one. So maybe we ought to adjust it so that it's more robust over a wider range of scenarios.
One way that I've found the use of scenarios in climate change different from how scenarios have been used elsewhere is the relationship of the external world and the decision maker. in the sense that the scenario is external to the decision maker. It's exogenous, as they say. I'm a business and I want to work through the scenarios about what might happen in my market. Suppose there's a disruption to a supply chain, energy prices go up. How would I respond? And it's stress testing my planning. Climate change is a little different because, yes, those are the scenarios that we're working with, especially in something like Working Group 2, where you're thinking about impacts. They're still relatively largely exogenous. But then you move into Working Group 3, where you're mitigating climate change, where you're reducing greenhouse gas emissions and atmospheric concentrations. The decision makers are trying to change which scenario they're in. But they want to move from a higher concentration scenario down to a lower one. So does this potential circularity between the decision maker and the scenario itself create problems, or does it create opportunities, or a little bit of both?
A little bit of both, actually a lot of both. So yeah, no, you're exactly right. I mean, that scenarios in their simplest case are external to your organization, and you adjust your own plans in response to these external scenarios, and that climate change intermixes what's internal and external in a pretty significant way. In a lot of the work we do, actually, where we do it's very regionally based. We'll say work with the water agency and look at how do they make their plans more robust and resilient to current and future climate change. You almost invariably find that the vulnerabilities of a plan and the actions that they need to take to become more resilient are intermixing of climate impacts and socio-economic drivers and things internal to their organization. So if you're really good at, say, implementing these new approaches which you've never tried before, and you actually implement them quickly, on schedule, and so forth, and your vulnerability to climate change is much lower. But if you fail to get your customers to respond in the way that you hope, then you in fact are very, very vulnerable. So that this intermixing of the internal and external is huge. In the climate change world, the vulnerability and exposure to climate change, and hence climate risk, can depend hugely on what your scenario is of future socioeconomic conditions. So even in Working Group 2, the internal factors can be gigantic. And if you look across different socioeconomic scenarios, the vulnerabilities to climate change can be vastly different. So yeah, so that is one of the big challenges that this sort of assessment and people trying to respond to climate change have to address.
The other aspect of scenarios in climate change that I want to dive into are specific to these RCPs. So to back up a little bit, RCP is Representative Concentration Pathway. These were developed in the late 2000s, and they're numbered. The number represents the magnitude of humans' impact on the energy balance of the planet at the end of this century. There were 4 RCPs. They had 2.6, 4.5, 6, and 8.5. And those were used throughout the 2010s. And it became clear that certainly the higher end scenario, the 8.5, wasn't really a possible future. Some of the underlying assumptions were extreme. It's still useful, of course, to have an extreme scenario to understand some of the potential worst impacts, to get a signal from the noise when you're running quantitative models. And likewise, the lower end scenario, 2.6, is a highly ambitious outcome that would require extremely aggressive emissions cuts and extremely aggressive removal of carbon dioxide from the atmosphere throughout this century. But what surprised me is, despite these criticisms and the fact that it appears heading towards down the middle, sort of the 4.5-ish range is about where we're at. If it's worse, it would be higher, a little lower. The way the RCPs were modified in this assessment cycle is they were actually made even wider. So 6 became 7, And then a 1.9 was put on the more optimistic side. And when I'm looking at it, we seem to be on track to sort of the 4.5 range, but we have this overabundance of scenarios at the extreme ranges and a lack of scenarios at the middle. And not only does this interfere with effective assessment, and that's one question I have for you, but it also creates this problem that then the news media picks up. Climate change will cause this and that impacts by the end of the century if we don't take action. But if we do take action, we'll end up at the most optimistic scenario, where in reality, the feasible futures are probably not as wide as the 8.5 down to the 2.6. So can you comment on that? Is there a lack in the middle and an overabundance at the edges?
Yeah, I think there's definitely a challenge here. And let me characterize two issues. I mean, one is this very high-end RCP, the so-called 8.5, which for a long time was the business as usual base case. And as you said, for a whole variety of reasons, that is no longer in any sense a base case or even a likely case. And it's taken a while to sort of flush that notion out of the system. I mean, as you say, it's useful as an extreme stress test case. It's useful to help calibrate analyses, but it's in no sense a base case. And I think sort of the bulk of the commentary and assessment gets that, but it's not universal, and it's still out there to confuse people. I think the other issue, which I do find as a challenge in this AR6 Working Group 2 report, is there's a lot of emphasis, quite rightly, on the difference between global warming of 1.5 degrees and global warming of 2 degrees, which relate to these very low-end RCPs. And because it's very important to make the point that even at relatively low global warming levels, there's a lot of damage. The risk and the damages go up non-linearly from even these low levels. But there is not as much as I would like to see about how one hedges against these higher global warming levels. Because as you say, I mean, the report made quite clear, Working Group 1 report, and then in this report as well, that the potential for going above 1.5 degrees and going above 2 degrees is very non-negligible. And there is not a lot. I mean, there's things in the report, but the report, I think, could use more emphasis on what are the hedging strategies against those very possible global warming levels. I mean, I think there's a reluctance to grapple with that question for a variety of reasons, including you might call the moral hazard problem. I mean, don't want to distract from the urgency of dealing with emission reductions. And also, it's hard in a consensus summary for policymakers that deals with people from all over the world to deal with these higher levels where there's going to be really differential impacts and ability to deal with those in different parts of the world. And particularly what the developed nations will, or the global north would have to do with the global south and those higher global warming levels is something policymakers don't want to get their heads around yet.
Well, to wrap up, I thought it'd be nice just to come back to the Working Group 2 again, because I feel that the media and the public and many people who have got to grips with this report have come across, it seems, a very dire picture that it's painted, where we're at and where we're going. Having been intimately involved in the process, have you left more hopeful or less hopeful?
Let's see where I am in a couple of weeks, but I think it's useful to describe it less as dire as a real emphasis on the urgency and the scale of the response that we now need to go to. So the report tries hard to get from the risk to solutions and this idea of transformation. And the things that we need to do, at least in broad outline, are starting to become pretty clear. And so you can definitely take the report as a message of urgency and what needs to be done. I suppose my main takeaway of the report is that transformation is inevitable, and either we can intervene and get a transformation that we like, or that we're going to get a transformation that we don't like. In some sense, there's no longer a status quo. The world is going to change over the next 10, 20 years in really significant ways. And we can either act and make that something that we like or not. And so I suppose for me, that's the big takeaway from the report.
All right. Well, thanks very much. Thanks for joining us.
Thank you. Thank you.
Thanks for listening to Challenging Climate. Our music is by Peter Downchuck, and our website is challengingclimate.org, where you can find the show notes for this episode, including all the relevant links and references. If you enjoyed this episode, please consider sharing it on social media to help us grow this podcast.